Here's another consecutive integer problem. 12 less than 5 times the smaller of two consecutive even numbers is equal to 4 times the larger of the numbers. Find the numbers. All right, so what are we looking for? We're looking for two consecutive even numbers. All right, so let's define them. The smaller even number and the larger. Now, these are consecutive even numbers, so the first one's n, the next one is 2 more than that. Anytime you're talking about consecutive even or consecutive odd, you have to add 2 to get to the next one. So what do we have? 12 less than 5 times the smaller. All right, so we're going to do subtract 12 from 5 times whatever the smaller number is. They say that's equal to just 4 times the larger one. So this is how you could think about it, sort of half algebra, half English. Now we're going to plug in how we define the small number and the large number. The small one was n, so 5 times the small is 5n minus 12. And the large one is n plus 2, so this would be 4 times n plus 2. So there's our equation, and now we're ready to solve. So let's do that. 5n minus 12, and we're going to distribute over on the right, equals 4n plus 8. So let's see, how about subtracting 4n from both sides and also adding 12 to both sides so that we have the variables on the left and constants on the right. That nicely gives us n equals 20. So it looks like the first number is 20, the second number is 22. Now let's see if this all makes sense. Are those two consecutive even numbers? Yes. Notice I just said numbers instead of integers, but when you're talking about even, you're really talking about even or odd. You are talking about integers. And would it be true that if I did 12 less than 5 times the smaller? Well, let's do it. 5 times the smaller, look here. If the smaller one's 20, 5 times that would be 100, right? And if I do 12 less than that, that gives me 88. Is that the same thing as 4 times the bigger number? Yeah. 4 times 22 is also 88. So the check, it all makes sense. You just go back to the words. It says find the two numbers. So all we're left to do is write the answer. The numbers are 20 and 22. Voila! Here's another problem. I am thinking of 3 consecutive integers such that 6 times the smallest integer equals 5 times the largest integer. What is the middle integer? Okay, we're dealing with 3 consecutive integers, so we want to start off with defining them. How about the first, the second, and the third? And since these are just consecutive integers, we just add 1 to get the next. We have n plus 1, and n plus 2. These will make the smallest one n. Now what's it say? 6 times the smallest, okay, so it says 6 times the smallest ends up being equal to 5 times the largest one. Now, I called it first, second, and third, but of course that would be the small, middle, and large, right? So for the small, 6 times n would represent 6 times the small. And for the large, 5 times the large, I'd have 5. The largest number is the n plus 2, so I have to put that in parentheses. And now we can solve. 6n equals 5n plus 10. Subtract 5n from both sides. And I get n equals 10. All right, what does n stand for? The smallest number. So the numbers are 10, 11, and 12 because they're consecutive. So first of all, we see if this is true. Is it true that 6 times the smallest one is equal to 5 times the largest? Well, 5 times 10, 6 times the smaller one. I did not 5 times. So I've got 6 times the smallest would be 60, and 5 times the largest number would be 5 times 12, which is also 60. So that all makes sense. Now we got to answer the question. What is the middle integer? Okay, the middle one must then be 11 right here, right? So the middle integer is 11. If it asked for the three numbers, we would say the numbers are 10, 11, and 12. We want to make sure we answer the question. Here we have another consecutive integer problem. If I subtract the largest of four consecutive odd integers from twice the smallest, the result is 7. Find the integers. Okay, this time we're talking about four odd integers. So we have to define four odd integers. But the first odd, the second, the third, and the fourth. So if the first one's n, since we're talking about odd integers, if you're talking about odd or even, you have to add 2 to get to the next one. N plus 2, n plus 4, and n plus 6. That's how we could define the four integers. So it says if you subtract the largest from twice the smallest, the result is 7. So we're going to subtract the largest one, right, from twice the smallest one, and the result is 7. So that's basically what it's saying, part English, part algebra. Now let's really fill in what we've defined the smallest and the larger one to be so we can solve this. So we have twice the smallest. Now the smallest was n, so twice the smallest would be 2n. And here's where a lot of people make their mistake. The largest is n plus 6, so a lot of people just write n plus 6. But this is incorrect. Can you figure out what's wrong? The problem with that is that you're just subtracting n. To show that you're subtracting the whole thing, you must put that in parentheses. And at the next step, you'll distribute your negative sign. If you didn't do that and you solve this equation without the parentheses, you'll get a different four integers. And as long as you check your answer, you'll see that there's a problem. But instead of doing it wrong, I'm going to do it right. 2n, and now you have to distribute that minus sign, so it's a minus n and a minus 6 equals 7. Remember to distribute your minus sign through the parentheses. And on the left side, we'll simplify by adding the like terms, 2n minus n. So we have n minus 6 equals 7, almost n. We're just going to add 6 to both sides. And to get n is 13. So it means that our first odd number is 13. So it looks like the numbers are 13, 15, 17, and 19, right? Those should be the four integers. Let's do a quick little check here. It says, if I subtract the largest, okay, what's the largest one? 19. I'm going to subtract 19 from something. If I subtract the largest consecutive odd integer from twice the smallest, all right, now the smallest odd integer is 13. So what's twice that? It would be 2 times 13. That's 26. The result is 7. Well, let's see. What happens when I subtract here? I get 7. All right, so remember the way we got this 226, that came from the 2 times 13. So that means our four integers are 13, 15, 17, and 19. Those are the four integers. If you want, you could write it in words. The four integers are 13, 15, 17, and 19. The thing to be careful of here is when you're subtracting a quantity like n plus 6, you must put a parentheses around it.